Hello class, welcome to Instruco. My name is Instruco Nishtha and I will be your maths teacher for today. So today we are going to learn more about fractions. Now fractions are very useful in day-to-day life and they help us solve a lot of problems, okay? So without any further delay, let's start with the lesson. So first thing that we need to understand is what is a fraction? Okay, so a fraction represents an equal part of the whole. So when it says it represents an equal part of the whole, so let's assume that there are four equal parts. Like here in this shape, you can see that this shape has been broken into four equal parts, right? So out of the four given parts, as you all can observe, two of them are colored and two of them are blank. So now if here I have to represent the colored portion using fraction, I can say that 2 by 4th of the image is colored. Why? Because the number of colored portion, that is 2, will go in the numerator and the total number of portions, which is 4 in this case, becomes my denominator. Okay, yes, you're correct. If the given fraction is 2 by 4, obviously we can write it in the lowest form as 1 by 2. Therefore it will also not be false if we say that half of the image is colored, right? Okay, now let's come to the next slide. Now here, as you can say, there are two measures. One is divided into 10 equal parts and the other one is divided into 4 unequal parts. Now, what is to be understood here is that fraction is only feasible when the image is divided into equal parts. If the image that we are talking about is divided into unequal parts, then I cannot describe it as a fraction. Let's say, let's focus on the image here, which is divided into unequal parts. This image here. So here, if someone asks me that let's say I have to select this 1 and 2 portions, okay? Now I ask you what portion of the image is selected. I definitely cannot say 2 by 4. It will be wrong. Why? Because these two parts are very small compared to the parts 3 and 4. So anytime for me to represent anything as a fraction, it should be broken down into equal parts. Okay, on this note, let's take a few examples, okay? So let's see. I have four oranges here. Okay. Now let's say out of these four oranges, you ate one orange today. Okay. So now that you ate one orange, if I ask you what fraction of the oranges have you finished, then the fraction becomes 1, the portion that you ate already, upon 4, which was the total portion initially. Okay, so if I asked you what fractions of the oranges is finished, it becomes 1 by 4. Okay, but similarly, if I ask you what fraction of the oranges is left with me, then what would you say? Yes, very right. Then the fraction becomes 3 by 4 because 3 oranges are left out of the total 4 oranges. So this is how fractions are very helpful to us. Let's make this example a little more interesting. So now I have 4 oranges and along with 4 oranges I also have 2 apples. Okay, now if I ask you what fraction of the fruits are apples, then what would you say? Can you think of an answer? Depends. See, what is the number of my apples? I have 2 apples. Okay, and what is the number of my total fruits? The number of my total fruits is 6. So automatically the fraction of apples among these total fruits becomes 2 by 6 because this is 2 parts of the 6 parts. I hope this is clear to everyone. Okay, if we talk about only these two apples, okay, and I ask you what fraction of the apple is green, then what would you say? As you can see, if I break this into two parts, then one part is green and one part is red. So half my apples are green and half my apples are red. I hope this is clear to everyone. Okay, while we are on the topic, let's see one more example. So this is a pizza. I'm sure all of you like pizza. Okay, so let's say you ate half the pizza. And now I'm asking you, what is the fraction of the pizza that is left? So your answer would be 1 by 2. Why? Because when you ate half the pizza, we broke this pizza into two parts. Out of those two parts, you finished one part. So only one is remaining. So out of the total two parts, one part is left. That would give me the answer as 1 by 2. Also, if I ask you what fraction of the pizza you ate, it would again be the same, 1 by 2. So basically, half of the pizza you finished and half is left, right? Okay, on this note, let's move on to the next slide. Yes, now see here in this example, I told you we cannot use fraction because this image was broken into unequal parts. Okay, but in the next slide, you can use fraction. Why? Because all my circles are broken into equal parts. Okay, so what is half? Half is represented by the fraction 1 by 2. Okay, so as you can see, this purple circle here is broken down into two equal parts. Okay, so each part represents the fraction 1 by 2. Okay, similarly, here the orange circle is broken down into three equal parts. Okay, so each portion represents the fraction 1 by 3. And here in the yellow circle, each portion represents the fraction 1 by 4. Now, one very interesting observation that you need to make here is ultimately half is when one whole circle is divided into two parts. So, let's say I add, sorry, so let's say I add half and half. Okay, so I'm adding two fractions, 1 by 2 plus 1 by 2. So my LCM here, LCM of the denominator will become 2 and my numerator will become 1 plus 1, which is also equal to 2. So my fraction is 2 by 2, which I cancel to get 1. So as you can see, when we add all the equal parts of the fraction, it makes one whole. It makes one whole number. Why? Because when we break it into fractions, we are dividing that one whole number only into equal parts. Okay, to prove my point once more, let's try to add 1/4. Okay, so like here in this figure you can see it is 1 by 4. In the yellow circle you can see it is 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. Now, if I have to see what does these four, when I add these four 1 by 4s, what fraction will I get? I will get 1 again. Why? Because in the denominator it will be 4 and my numerator it will become 1 plus 1 plus 1 plus 1, which is again equal to 4 by 4. So this whole circle represents one circle and it is broken into four equal parts. That is why my fraction is 1 by 4. That is why the fraction of each quadrant is 1 by 4. Okay, now whenever the fraction is 1 by 4, it is called quarter. Okay, 1/3 is called 1/3 and 1 by 2 is called half. Okay, so basically to say, two 1 by 2s make one full, three 1 by 3s make one full, and similarly four 1 by 4s also make one full. Okay. Okay, now here we have a warm-up activity to understand fractions better. Okay, here it says, what fraction of each figure is colored? Click on the fraction that matches the figure. So we have to write down the fraction for the colored portion of each figure. Okay, so like I said, here it is asking what fraction of each figure is colored, right? So and as you can observe here, each figure is divided into equal parts. Like if we talk about this square here, all the four smaller squares are equal, right? So wherever it is like this and it is being asked that what fraction of each figure is colored. So the colored parts will come in the numerator and the total number of parts will come in the denominator. So here for the first figure, my number of colored part is 3 and my number of total parts is 4. So to say that 3 by 4th of the figure is colored. Okay. Okay, let's move to the second one. Here in this case, my one part is colored and my total number of parts is 3. So I can say that 1/3 of the figure is colored. Again, if we come to the third example, you will see that here again my 4 parts are colored and total number of parts are 8. Okay, so I can say that 4 by 8 of my figure is colored. But now this 4 by 8 is not the lowest form. Okay. So we can reduce it further. How can we reduce it further? How about if we write 4 as 4 multiplied by 1 and we write 8 as 4 multiplied by 2? So now, since we have equal numbers in the numerator and denominator, they will cancel each other. So my remaining fraction is 1 by 2. So instead of saying that 4 by 8th of the figure is colored, I could also say that half of my figure is colored. Okay, so I hope such examples are clear to all of you. Let's continue with something new now. Okay, so here, as you can see, a circle is divided into 5 equal portions. Okay, and out of which the one portion is colored. So if I ask you what fraction of my figure is colored, so what will the answer be? Number of colored portion, which is 1, upon total number of portion, which is 5. Similarly, here if I ask you what portions of my figure is blank, then what will you do? Since 4 parts are blank, so we write 4 in the numerator and my denominator will always be the total number of parts, which is 5 in this case. Okay. Similarly for this, here I can say that 2 parts are colored. So the fraction of the colored figure becomes 2 by 6. Okay. Now, here what do we need to do? We need to match. So here you can say there are 3 figures given to me. One is A, one is B and one is C. So I have to say which of the following models shows the fraction 1 by 7. Which of these 3 figures is showing the fraction 1 by 7. So let's see. Okay. The first one is showing the fraction 2 by 4 or 1 by 2 because 2 parts out of the total 4 parts are shaded, which when we convert to the lowest form will give us half. Okay, so first one is not the correct option. Now let's come to the second one. First things first, we will count the total number of parts here. So total number of parts are 1, 2, 3, 4, 5, 6, 7. So our denominator becomes 7. Now what is the number of shaded parts? One part is shaded, right? So we got our answer here, right? So the B model shows the fraction 1 by 7. Okay. Okay. Now we will solve similar questions in this worksheet. Okay. So here we have to write the fraction representing the shaded parts. Okay. So again, let's come to the first figure. In this, the total number of parts are 3 into 3, which is 9. So my denominator becomes 9. And what is my shaded number of parts? 1, 2, 3, 4 and 5. So if I have to represent the shaded parts using a fraction, it will become 5 by 9. Okay. Similarly here, my total number of parts are 8 and my shaded parts are 4. So the fraction representing the shaded part becomes 4 by 8, which is also equal to 1 by 2. Now, while we are on this topic, I would like to tell you one more thing. So as you can see that the value of 4 by 8 and 1 by 2 both is same. Right? 4 by 8 is also 1 by 2 and 1 by 2 can also be written as 4 by 8. How? When we multiply the numerator and the denominator both by 4, we will get 4 by 8 only, right? So such kind of fractions are called equivalent fractions. As the name suggests, because they are equal, they are called equivalent fractions. Okay, let's move to the third figure now. Here, the total number of parts are 1, 2, 3, 4, 5, 6, 7. So there are total 7 parts, out of which 5 are shaded. So the fraction representing the shaded part becomes 5 by 7. Okay, let's do one more example like this. Let's take the second example here. So total number of parts are 3, 3, 6, 3, 9, 10, and 10 plus 10, 20. So what will be my denominator here? My denominator becomes 20. Now let's see. Here the question is asking what fraction represents the unshaded parts. So please focus. Till now in the last exercise we were doing the shaded parts. So that is why we were counting how many boxes were shaded. Like in this case we said 1, 2, 3, 4, 5. So because 5 boxes were shaded, so we put 5 in the numerator. But here, since they are asking the number of unshaded parts, the we will have to count the number of unshaded boxes. Okay, so let's see: 1, 2, 3, 4, 5, 6. Similarly, here we have 7, 8, 9, 10, 11, 12. So if I have to see what fraction represents the number of unshaded part, it becomes 12 by 20. Now think, is this 12 by 20 in the lowest form, or can we reduce it any further? Absolutely correct. This both of my numerator and denominator are divisible by 4. So why not we just divide both the numerator and denominator by 4 and convert this fraction to the lowest form? So 12 divided by 4 becomes 3, and 20 divided by 4 becomes 5. So I can say that 3/5 of my image is shaded. So now 3/5 of my image is shaded, and my whole image was representing 1, right? It was one whole image out of which 3/5 is shaded. So 1 minus 3 by 5 will, out of which 3/5 is not shaded, right? So 1 minus 3 by 5, which is equal to 2 by 5, will give me the fraction of the shaded portion also. So here 3 by 5 represents the unshaded portion, whereas when I subtract the same fraction from 1, I get the fraction for shaded portion. Also, we can check it the other way around like we were doing till now. So out of 20 parts, since 12 are unshaded, so what is the fraction of my shaded portion here? 8 by 20, because 8 parts are shaded and my total parts are 20. Again, if you divide it by 4, you will get 2 by 5 only, right? So these are just two methods of obtaining the same answer. Okay, let's continue to the next slide then. Here it says, click on the parts in the given models to represent the fraction, okay? So if I have to represent the fraction 2 by 6 here, so total there are 6 parts, so denominator has already been represented. Now how do we represent the numerator? So how about if we shade 2 parts? If we just shade 2 parts of this image, then can I say that 2 by 6 is represented by this image? Similarly, if I have to represent 5 by 8, I will shade 5 parts, right? Which would make this image as 5 by 8. So now here 5 by 8 of the image is shaded. Similarly, here we can shade 7 parts and represent the 7 by 8. Okay. So basically we will shade just the center portion. See, center portion is 7 parts, right? So once you shade the center portion, now 7 by 12 of my image is represented, out of which 7 parts are shaded and remaining parts, which 2, 3, 1, 2, 3, 4, 5. Okay, Here, instead of shading 7 parts, we have shaded 8 parts by mistake. So we will have to exempt one more part. So how about we shade just this much, right? Now, as you can see, that 7 parts are shaded and 5 parts are unshaded. So now this figure also represents 7 by 12. Easy, right? Fractions are not only easy but very interesting also, and they are very useful in day-to-day life. Okay. Okay, now again, same thing. There are figures broken down into equal parts, and we have to say what fraction represents the shaded part in the given model. So, since again it is asking what fraction represents the shaded part, so we will write the number of shaded pieces in the numerator. So, for the second example, we can say that the shaded pieces are 4 and the total pieces are 7. So 4 by 7 represents my shaded parts. Let's do one more example. Here 1, 2, 3, 4, 5, 6. 6 parts out of total 8 parts are shaded. So the fraction representing the shaded portion becomes 6 by 8. Okay. And what about this? Here we have 5 parts shaded out of total 10 parts. So here I can say that half of my image is shaded. Okay, let's continue. Similarly, in this question, we have to represent the fraction that is given to us using okay, using these bar models. Okay, so if it says 1 by 6, I would simply shade one portion of the 6 given portion. If it says 5 by 7, I would simply shade 5 portion of the given 7 portions. Right? That is it. So this is very easy, I hope. Okay, let's move to the next slide. Okay, now what do we need to do here? Here there are 4 images given to us, each of which represent a certain fraction. So all you have to do is match the following. Okay, let's see how we'll do it. So here, if we talk about the first image, which is completely blue, I don't have to tell you that with just looking at it, you can tell me that, ma'am, one whole image is blue, right? Correct. So the fraction here would be 1. 1 is not a fraction, 1 is a whole number. So basically, this is a whole figure that is shaded, okay? But if I have to represent it into fractions, what will I do? What are my total number of parts here? 1, 2, 3, 4, 5, 6, 7, 8. So my total number of parts here are 8 and all 8 of them are shaded. So the first figure is represented by the fraction 8 by 8. Easy? Okay, let's come to the second figure. My second figure has been divided into 12 parts, out of which 3 parts are shaded. So, which is the fraction representing this figure? Yes, absolutely right. It will be 3 by 12. Okay, let's look at the third figure. What are my number of shaded portions and unshaded portions here? Let's count the number of unshaded parts, half of which is unshaded and half is shaded, right? So the number of unshaded parts here is 10. So 10, since 10 parts are shaded and 10 parts are unshaded, so the fraction represents 10 by 20. Why? Because my total number of parts is 20, out of which 10 look different and the remaining 10 look different. Right? Okay. Let's come to the fourth figure now. Here, out of the 8 parts, 4 are shaded. So the fraction represented here is 4 by 8. Not only that, we can also say that half of my image is shaded here. Here also I can say that half of my image is shaded. Here I can say, since the shading is 3 by 12, so I can say quarter of my image is shaded or 1/4 of my image is shaded. And here one full image is shaded. Now 1 can be written as 1 by 1 or it can also be written as 8 by 8, because here in this case when I divide the numerator and denominator both by 8, I will get 1 only. So I hope all these questions are clear to you. Okay, let's do one more example. Now, this example is based on the example that I gave you before this, the example of apples and oranges, right? So, like we had apples and oranges, here in this example, they have strawberries and oranges, okay? So, if I have to tell you, this group of fruits has been divided into 8 fruits, okay? So, it's 8 parts. So, number of strawberries is fine, 5, and number of oranges is 3. So if I have to ask what fractions of the given fruits represents the strawberries, so strawberries is represented by the fraction 5 because there are 5 strawberries upon the total number of fruits, which is 8. So 5 by 8 fraction represents my number of strawberries. And if I have to ask you what fraction represents the oranges, so again, since total number of fruits is 8 and out of those 8, 3 are oranges, so the fraction representing the oranges becomes 3 by 8. Okay. Okay, now we will see same fraction, but we will represent it on a number line. Okay, so now here, as you can see, my number line is divided into 1, 2, 3, 4, 5, and 6 equal parts, out of which one part is shaded. So if I ask you what fraction of the number line is shaded, you will give me the answer as 1 by 6, because one part is shaded out of the total 6 parts. So shaded portion is represented by 1 by 6. But now similarly, if I ask you what fraction of my number line is unshaded, so this case we will write the number of unshaded portion in the numerator, which is 5 upon total, which is 6. Okay, similarly, let's see one more example here. What fraction of this second number line is colored? So as you can see, the total number of parts this number line is divided into are 5, 6, 7, and 8. So this number line is divided into 8 parts, out of which only 3, 4, and 5 is colored. Means only 3 parts are colored. So the shaded part or the colored part is represented by 3 by 8. So I hope all these different representation of fractions are clear to you and you enjoyed my class. Okay, so on this note, I'll stop the lesson here and I'll see you again in my next video. Bye kids, have fun, have a great day.